In this example, we are going to graph the polar curve r equals 2 cosine of 2 theta plus 1. So my curve is r equals 2 cosine of 2 theta plus 1. And just like I generally do, I'm going to use the graph of the Cartesian equation y equals 2 cosine 2x plus 1 to help me. Now if we look at that curve, y equals 2 cosine 2x plus 1, this is what it looks like. And the points that I want to pay particular attention to are the points where this curve either has a maximum or minimum, so that would be at 0, at pi over 2, at pi, 3 pi over 2, and at 2 pi. And also the points where y is 0, because y, remember, is r. And so that tells me where r is 0, or where I go through the origin on the polar curve. And it tells me also when r is switching from plus to minus or from minus to plus, and so the curve might switch into a different quadrant at those points. So those are important points to look at. Okay, so let's start at the beginning with theta equal to 0. I'll make a little chart like I usually do over here of the important points. So certainly theta equals 0 is an important point. And at theta equals 0, that corresponds to the positive x-axis. So that's the ray theta equals 0. And if I plug in theta equals 0 into my equation, I get 3 for r. So I'm going to start 3 units from the origin along that ray. So that's the point I start at. And then I look at the curve y equals 2 cosine 2x plus 1 in the first quadrant, and I see it's going to cross the x-axis. So let's just graph it up to the point where r is 0. So I'm going to need to know where that is. So let me go down here and figure that out. So if I set 2 cosine of 2 theta plus 1 equal to 0, that means cosine of 2 theta would have to equal minus a half. So let's see, what angles have a cosine equal to minus a half? Let's see, there's one in the second quadrant, which would be 2 pi over 3, and one in the third quadrant, which would be 4 pi over 3. And that means theta is half, so pi over 3 and 2 pi over 3. So those are definite points that I want on my list. So we'll put theta equals pi over 3 here. And we know that r is 0 there. So theta equals pi over 3. That is this ray. And I am looking at these angles now between 0 and pi over 3. So that's where my curve is going to go as I look at this part of the curve. And r is starting at 3 units away from the origin and ending 0 units away from the origin. So my curve is going to go through these angles starting 3 units away from the origin and ending 0 units away from the origin, something like that. Okay, now we'll make our way through the rest of quadrant 1. So the next point on my list is going to be pi over 2. And r is going to be minus 1 there. So theta equals pi over 2. That is the positive y-axis. but r is -1, so really my point is going to be on the negative y-axis, right, 1 unit away from the origin, so that's right there. And I'm looking at angles from pi/3 to pi/2, but because r is negative, I'm really going to draw my curve over here. So starting at the origin and ending 1 unit away, so something like that. Okay, so we're done with the first quadrant. Now on to the second quadrant. So in the second quadrant, the first part has negative r's. So I have to put on my list the point where I'm going to cross the x-axis, which is the other theta that we found over here, which was 2 pi/3. So that's going to go on my list. And we know r is 0 there. So 2 pi/3, that is this angle right here. Oops. Right here. Theta equals 2 pi/3. And r is going to be 0. And so I'm looking at angles between pi/2 and 2 pi/3. But because r is negative, right, I'm over here in my Cartesian graph, my curve is going to be drawn over here. And I'm starting 1 unit away from the origin at pi/2 and ending 0 units away from the origin. So something like that. All right, the rest of quadrant 2 would get me to pi. So let's put that on my list. Pi. Cosine of 2 pi is 1, so r is going to be 3. So theta equals pi, that's this angle. And r is a positive 3, so I am going to be right on that axis, right there, 3 units from the origin on theta equals pi. And I'm looking now at the angles between 2 pi/3 and pi. So that's these angles, right? And r is positive, so my curve is right in that region, starting at r equals 0 and ending at r equals 3, so like that. Okay, quadrant 3. So now part of it is above the x-axis and part of it is below, so we'll do the part above first. So where am I stopping there? So there must be another theta where r is 0. I only found 2 angles over here, but there must be another one. So I can get the next one by just adding 2 pi to the ones that I have. So if I add 2 pi to 2 pi/3, that's 8 pi/3. And I might as well do it with the other one as well. So 4 pi/3 plus 2 pi is 10 pi/3. And that's 2 theta, so theta would be half, so 4 pi/3 and 5 pi/3. So 4 pi/3 is the next one on my list. And I'm going to have r equal to 0 there. The ray, theta equals 4 pi/3, is this one. I'm looking at angles between pi and 4 pi over 3. So those are these angles. And r is positive, so that's where the curve is. And it starts 3 units away from the origin and ends 0 units away from the origin. So there's that part of the graph. Then the rest of quadrant 3 ends at theta equals 3 pi over 2. So that's my next point on the curve, on the list. And when theta equals 3 pi over 2, r is minus 1. So 3 pi over 2, that's this ray. And since r is minus 1, I'm really on the positive y-axis at 1 unit from the origin. So I'm going to be there. I'm looking at angles between 4 pi over 3 and 3 pi over 2. So so these, I guess I already did this, but I was in a different quadrant. So now I'm going this way, right? But I'm negative, so r is negative, so I'm really over here. So I'm drawing it right there. And then I'm now going into quadrant 4. So, and again, I'm going to hit r equals 0 at some point, which we already found that point to be 5 pi over 3. So there's my next angle. R is 0 there. So 5 pi over 3, that is this ray. And r is 0, so I'm going to hit the origin. I'm looking at angles between 3 pi over 2 and 5 pi over 3. So I'm looking at angles in here, but r is negative, so I'm really looking to draw my curve in here. So that will go like that. And then we'll finish off quadrant 2 by getting to 2 pi. So that's the last point I'll put on my list. And when theta is 2 pi, r equals 3. So that puts me at the point where I started my curve. I'm looking at angles from 5 pi over 3 to 2 pi here. So let's see, let's do this color. So I'm looking at these angles with a positive r, so that means that's where the curve is. So I'm going to draw my curve starting at r equals 0 and going to r equals 3 on this part of the graph. And I think I'm done. So that's what my curve looks like. I can show you a better picture if I view graphics 2. So there's what the curve should look like, and you can see it being generated from the beginning. So as I go around, so I hit 0 and then I switch over to quadrant 3 and then I hit 0 again and